So thank you, Tom, for joining me today, just for fixing the error appeared during the Saturday about the session for the class. So somehow
Yeah.
the Zoom wasn't broadcasting, so we have to re-record the session. And right now, thank you for this. And if you want to say something before start sharing my screen for this.
Yeah, you bet. In fact, there's some advantages to getting to redo it. Um, we already had a really great class. You already did a great job presenting it. But the nice thing is we got to refine how we're going to answer the questions and to deal with some feedback. And one thing, Geith and I want to point out to everyone that's watching this, hopefully rewatching it, is this. We're just trying to show the bigger community that data scientists are part of. Guy's going to show some things about application lifecycle development principles. It's not that every data scientist needs to be an expert in the things we're going to talk about. What's really important is to be aware of it and to become more aware of it and know how to better fit into it when you're in your teams. But I want to also point out that the experience you have on one team, you move to another company, and the setup, the tools, the way they go about this specific methodology can feel quite different. But overall, at a high level, these things that Guy is going to talk through, we've both seen them in our careers. And the more aware of it you are, the better you're able to fit into it and be a good data scientist in these environments. That's what I wanted to add starting out.
Yes, I totally agree with you. And this is also some feedback we received that, yes, is this all of this we have to consider? No, all of this we have not to be 100% professional using it, but we have to know where are we in this ecosystem, let's say. So I will share my screen now to tell everyone about
Exactly.
software engineering for data science, for machine learning. So from where this, when I talk about the pipeline, and during speaking about the pipeline, we have multiple tasks, and also if we map each task to the person or to the rule that performing this task, we have some rules also, just like machine learning engineer and machine learning operation, ML ops, data scientist, data engineer, from where all of this comes. In fact, it's kind of another implementation for methodologies that used in each and every engineering sector in the science or in our life, in the production life. One of them is the software engineering, and which is very important because it's interacting to understand this, because it's interacting deeply with machine learning project. In fact, to understand how it's interact, let's start with this presentation. Now, the organical or logical host for any machine learning model is a software model or a software project or product. Maybe it's web API, maybe it's Windows application, whatever kind, or mobile application, whatever it was, the shape or the format of this software, but it is the expected host for the machine learning model. It's the interface that make the machine learning model able to be interact with the world, with the users, with other systems, whatever. So in fact, we found who's also following me and I'm also following most of them on the LinkedIn. In one post, we mentioned that there's three levels of software development involvement with the machine learning. One of them that the data scientist might write a piece of code to perform something and make it automated just to follow his process until he finish his experiment. Maybe it will be for visualization, for making mathematical operation, and he is thinking about using it for this task only. So this is the, let's say, the basic level of involvement with software development. The second level, it's you are building kind of procedure or method or functionality, and this functionality can be used in other projects also. So it will be kind of automating for, let's say, one task. Maybe it will be one task of our pipeline. The third level, it will be building the software backend. And when we are talking about these three levels, we have to rethink again about software development lifecycle, and then we are talking about something bigger a little bit or more common, more generalized, which is application lifecycle. In application lifecycle, we are dealing with application that working and serving on the real life and what kind of concern. Now, I'm not showing any implementation for application lifecycle. What we are going to speak about it right now, it will be all the concern that we have to take care about. Maybe we miss something, but at the end, most of them, to take care about when we are dealing with the application serving on the real life. Now, how to implement this? There is multiple ways to do that. There is some frameworks or some tools already developed to do that, some standards we can follow. Now we are mentioning the concern only because it's not our focus. It's part of our introduction to tell you how the application lifecycle interacting with machine learning pipeline and data science lifecycle. So when we have applications serving on the real time, we are talking about version. Which version of this application is serving? Now, right now we will consider the version I, and then for sure maybe there is some versions was before that, and there is also new versions will come in the future. But for any version, we will start from change request comes from the stakeholders or the users. Most of the change request comes from the stakeholders. Even if we are talking about the version 0 or the version or the beta version or the version 1, it's already triggered by change request from one organization or one stakeholder telling you that, okay, I want to automate this process. I don't want to use, for example, the manual process again. So at the end, change request is triggering the application lifecycle in software engineering. And once we receive a change request or a set of change requests, we are going first of all, either for current running application or for brand new application. We are going to validate it. It's really able to meet this change request or not, according to the current situation from the business point of view. And then we are going to prioritize this change request to see which is the most important, and we have to meet as soon as possible. At the end, we are going to create a bank of change requests, and it's prioritized. According to that, we are going to revisit it again when we are moving from one release to another, and also for sure when we are moving from one version to another. Okay, I think here I'm not going to mention what's the difference between version and release until I finish, but I will back to it. Okay, now once we prioritize the change request, we will start with our plan. Our plan will consider how many change requests we are going to include in the current release. What is the resources, human or material resources that going to be used? What's the team member they will be with us with the rules of and each part of team member, and what's the task we have to follow until we finish this release. This plan, it's kind of here, which is the project manager usually who doing this. It's a kind of being sure that all the resources needed it's available with us, and according to that we are expecting a specific timeline to perform this chosen change request. That means not all the change requests will be on the management because it will be in this release, but at the end we have the bank of the change request, we have a backlog for it, and we are trying to meet and finish all the change requests that we have. This is in general the mentality of the application lifecycle. Once we finish from this part of planning, we are going to the design part. And in the design, we are going to translate the change request into requirement. And requirement will have two parts. Requirement, in fact, how to differentiate between requirement and change request. Change request, mainly, it's going to tell you the target. It's coming from the stakeholders. Requirement is going to tell you what is the current process and how we are able to improve it or to change it to meet that target. So the requirement is coming from the user, from the end users, but the change request is coming from stakeholders. Now we have to collect and analyze this requirement. There is many forms to make the requirement analysis. The most common one, it will also integrate, let's say, interact with the system analysis, with its requirement telling you that this is what user need. System analysis is telling that this is our vision for meeting the user requirements to perform the change request need asked from the stakeholders. So system analysis, we are able to use, for example, use case diagrams and or use case scenarios, which is kind of script, templated script. It's very nice to explain all the rules, all the scenarios that we are going to face. Or maybe we are able to use user stories, which is very short but also effective way to make the system analysis with, for example, PPMN. And here's one question appeared in the session: business process modeling notation. So this is what the PPMN stand for. In fact, it's not our, let's say, we are not focusing on the PPMN in this course, but it's good to tell you that PPMN, it's a kind of workflow or flow chart. It's able to be automated and generate a code, uh, let's say, automatically. And there is some tools already doing that.
And
Okay.
I'll just quickly add, guys, that the Wikipedia page for BPMN is really well done.
In fact, yes, Wikipedia page is great. Also, there is some resources it's telling you, and also there is some multiple, by the way, multiple way to implement the standards PPMN. One of them, it's Java framework called. Really, I am from Saturday until now. I'm trying to remember, and I avoiding myself to search on it. This framework, what it's doing, you are only, let's say, determine what is the pool of your application, what is the rules of your users, and what's the task um, with all the conditions, and then it will generate, uh, let's say, all the APIs needed to serve this application, and the developer only has to think about the user interface. So mainly it's creating the business logic totally, who is coming from 3 tiers programming. So this common business logic is common term there. Now, with the design also, we have to choose the, let's say, the engineering, the real engineering part of the design of the system, which is what is the design pattern we are going to follow. And design pattern, we have two kinds of design patterns. One of them is behavioral, that it's describing how the data will move from one entity to another. And the other one is structural. In fact, it's describing what is the most effective way to create your object and to release the memory. And when we are going to release the memory, and what is the, let's say, the best way to implement multitasks for the same objects. All of this is coming from the design pattern. One of the most important design patterns, if we are able to name it as design patterns, is the microservices. Now, briefly about the microservices is you are splitting your application into standalone tasks or piece of code or piece of, uh, let's say, of procedures. It can be standalone, and it will be all needed environment, all the needed environment to serve it. It will be also there. Now, all of this can connect, all of these pieces can connect to each other using the workflow that you create in the system analysis. Okay. And also it can be used in another project. So it's a great idea, the microservices, but also it's need a lot of settings, a lot of let's say, a lot of deployment requirement, a lot of scaling requirement, which is right now, which is named DevOps, and which is similar to the MLOps that we are going to discuss later in this session. So microservices, one of these procedures or methods in the microservices can be machine learning model, which is generated and tested by the pipeline. So exactly this is what happened. Now, once we finish from the design, we are going to run our sprint. Sprint, it's coming from the American football when the team is gathering together and then they are running the sprint until they get the point or hopefully will not lose the point. By the way, I'm not big fan of the American football, but this sprint, it's going to tell you that whatever you are planning and what is the design you are preparing, you have to go ahead and performing it. And at the end, the result, it might be only software piece or software piece which is serving data science model, or software piece which is complicated, serving multiple data science model and multiple other software pieces. So in fact, the target, and which is here you can see the three levels also of involvement of software engineering with the data science. When we finish from this sprint, we are going to release this version and think about how it will be integrated with other piece of projects, or with other projects or other applications or other piece of codes, how to merge it and how it will be integrated to each other. And here's where the DevOps works appear very important. And one of the most important tasks is how to scale these services if we are following microservices, because maybe a lot of requests can come to one procedure, and this procedure has to be scaled and duplicated. So each one, it has to serve a couple of users or set of users. And all of this has to be also monitored and has to be archived. So all of
And
this.
guys, just real briefly, some of our students are new to this field. In fact, we learned from a survey that very few of them come from a software engineering background. Just give them a brief explanation of what DevOps really is.
In fact, DevOps, it's appeared once we have application hosted on the cloud. And with the cloud, that there is a lot of, let's say, predefined services, that which is previously what was managed by, we used to name it that, let's say, the IT management, or the IT information technology support team, which is preparing the servers, and then how these servers will host the databases, and how it will host the codes or the application, the release, and then how it will be interacted to each other. All of this, when we move to the cloud, it's becoming first, it's predefined, but also it's coming with extra services. So in fact, here there is something disappeared, there's some responsibilities is disappeared, because once we, for example, the developer working on the sprint, they don't have to think how to release this sprint. There is another rule, another person who is preparing all the environment, and it will be integrated with the cloud, whatever was the cloud environment there, and preparing all the settings to automate the deployment, releasing, and serving process, and even automate the scaling when we need scaling, automate the logging action, the actions, and let's say tracking and monitoring the performance. All of this, it will be automated with some kind of settings, and the DevOps, who's the person who's able to prepare everything, and also he have good knowledge about the software engineering or software development process, because he has to understand what is the most critical services from his application to give it the priority here. So this is the DevOps, in fact, is the person who's orchestrating all the actions on this application lifecycle.
And I'd just like to add, the groups that I've been a part of, it kind of depends on the type of models and the type of software you're serving up. When I went from the three different ones that I've been part of at a large scale, they were all a little different, but the key was that they were all automated, and it was just you learning how to fit into the process. But again, awareness of all this ecosystem for software development and how the data scientist fits into it, that's what's the real takeaway here.
Exactly, Tom. This is why right now maybe we are mentioning something like system analyst, business analyst, project manager, DevOps, software developers, and data scientists. In fact, this is the team that we expect, maybe all of them or some of them, that always we are working with as a data scientists. So this is how we understand our team is, let's say, formed, in fact. Now, for sure, we are expecting iterations here. Once we finish this release, we will back again to the change request bank, choose what is the most important, and also if there is any change request, new change request appeared, it will be prioritized there. again, create our plan, the next release, and then we are going to decide when it's the next version, if there is a new version will be appeared. And at the end, we might face that there is retirement, either on the version level or on the application level. But most of the time, we are talking about retirement about the version level because we are not going to support that version anymore. We will back to, for example, for the newer version. This is what we are facing on the current life. Now, I will make this move right now. This is, in fact, one important point that during the session on Saturday comes from Greg. It's about the testing. In fact, I didn't mention anything about the testing here, but yes, the user acceptance testing, unit testing on the software development part, which means on the sprint part. Um, Another kind of test, which is stress test, for example, always it's needed. But what is determined exactly? What is the test needed? In fact, it comes from the management point of view. In the management, project manager is decided when the test will happen and what's the time allocated for the test. And also in the system analysis, in the design part, because part of the system analyst task is to determine what is the test will be performed, what is the output of that test, and the client or stakeholders or project owner has to approve this. So in fact, if we don't have this in the system analysis document, um, the project will never finish, let's say. So it's important to add this, but I didn't add it because I'm building this from kind of concern, and my concern mainly it's about the rules that we are going to face. So the testers, it's part of the software team, and sometimes it's part of the stakeholders, sometimes it's part of the users, and all of them it's already mentioned.
And another quick point to add, for those of you that are completely new to this and trying to see, well, where is my place in all this? Understand that this is the big picture that machine learning fits into. It's not this fitting into machine learning, it's machine learning and the pipeline of machine learning that fits into this bigger ecosystem, this bigger process. And that covers a question we were also asked in the original lecture.
Okay, now starting from this point that you mentioned, Tom, if we consider any data science model node here in this in the sprint, and we want to go in depth to see what's happened under it, under this node. That means we are trying to see another dimension of this ecosystem. It will show us the data science lifecycle and the pipeline. So mainly, this is what we are seeing under the data science model, any one of these data science model. This is what we are seeing right now. Here, the data science lifecycle, which is managing any data science experiment. We are expecting, as we discussed in the first session, we will have reporting or presentation or another software piece of code or procedure or machine learning model. And once we are talking about machine learning model, we are going to discover what is the requirement also again to build this, why we choose to work on machine learning model, to solve our problem with machine learning, and to make this decision. And we have to understand the business, what they have, what is their concern, what kind of decision, how this model will serve them, and understand the data that we have, because understanding the data will help us to create the plan of modeling. Once we understand all of this together, so the requirement here, it's related mainly to the business process that we are serving, and the data we are going to use to build our model. Once we have the requirement, again, we are going to create a plan with a team, the suitable team, with the resources, which is, this team is part of the original team, by the way. This is what we have to understand. This team here, it's a sub-team from the original team that working on the full ecosystem that we showed previously. The resources that we are going to use and what is the task. And then we will start from the data processing. Here is the pipeline exactly. Now, after we have our plan and we understand our requirement, we will start our pipeline from.
Real quick, guys, before
Yes.
you go into that, I just want to say, if you've watched what Guy and I post on LinkedIn, what we talk about in our mentoring sessions, this gets down to that caring. I mean, you see people arguing about being data driven, and that's correct. In other words, it's this understanding the business needs. Now go understand the data that we have that will support that. If the need is really big, we may need to start collecting the data for that need because maybe we hadn't been collecting it. Maybe you're in a type of business or organization where we've got to go survey to get that data. But that always goes hand in hand with management because they're the ones running the greater business. They have to agree that this is where we want to aim our resources. And so these two top points are so foundational and key before we start taking the time to do the pipeline. In fact, I would venture to say that large number that you hear of projects, machine learning projects that never get incorporated, they're probably because a good job wasn't done on the requirements in the management.
Okay, Tom, that's perfect. Now I'm not going to explain again what is the steps or the task in the pipeline. But here, whatever I mentioned here, it's already mentioned in the first lecture. I maybe add one thing, which is when we are building the model, we have to consider the learning method. In fact, when we are considering the learning method, it's depend on also how the model will serve the user, how the model it will be in use. Because if the model is involved with edge, let's say machines, just like mobiles or Internet of Things, IoT machines, or just like autonomous cars, then there is other methods of training will be used to be more effective. We will try to explain some of them during the class itself. So whatever here in this pipeline and under the pipeline, which is the orchestration and the versioning nodes, it will be our class. But why we make all of this introduction, just to tell you how this is fitting on bigger picture, which is the software engineering and how software engineering is the real interface that help the machine learning model to be in use in the real world. So this is where we stopped on Saturday, and we'll stop on the same place. I'm not going to speak on this. We'll keep it for later. Now, Tom, since you have the question with the help of everyone, thanks for, I think, Valerie and Vikram. I think they provide this question to us. So
Yes,
just if
they
you
were
are
very...
going to go, I will stop the share and we are going to answer the question.
Excellent. So in that slide set, we did see, and Magdi asked, what is K-fold cross-validation? And it's a type of training method to make sure that you've used your data training and testing in a way to try to maximize the generalization of your model. So it'll work well on new data. Again, nothing we do is perfect. All models are wrong, but some are useful. But the K-fold method is a very powerful way to try to help you ensure you're finding the model that generalizes the best. And then
Tom,
asked,
I have one comment. I want to make it from Saturday, but I miss it. In fact, the K-fold, when we are talking, it's here we have to differentiate the scenario and we have to understand our data size to decide when we are going to use the K-fold, because it's using the whole data and multiple runs. It's K-run, that means maybe it's 5 times or 6 times or 7 times. And when we are going to split the data and make the validation according to the train, validation, and test set, or train and test set. Because if we have a huge data, the K-fold, it will not play main role in the deep learning scenarios, in fact, with the big data. It will not give us the benefit needed comparing with the time that we spend. And especially if we don't have the, let's say, fantastic machine or supercomputer that we are going. For example, if I'm using my CPU for my laptop to train them. So in that case, we have to go for the, and this is will show it during the class, to go to, or just split our data into train and test set, or train, validate, and test set, it will be more active. But the k-fold, it will be fantastic when we are talking about smaller size of data to train, let's say, a big model. Here it will be just great.
Yes, good. I'm really glad you added that. Um, Avinash had asked, are we going to see the whole life cycle, and how is it being implemented in machine learning during the course mentoring journey? No, we're not. We're really going to focus on the machine learning pipeline. We just wanted you to be aware that the machine learning pipeline is part of a bigger system. And then, okay, we did k-fold cross validation. We talked about BPMN, that was great. Greg asked, what's the difference between deploying and serving? And it's really just launching and keeping it going. I think you covered it really well with these new slides. And then, so when we scale data, that's like normalizing the data. We'll be doing that a lot in our course. And by the way, all these slides will be made available for the class. And then Vikram added a really important comment. In my companies, data scientists deal mostly with building models, and the rest of the process is carried out by the software engineering team, like data engineers, et cetera. And he's spot on there. That is absolutely correct. And then, but it's interesting that machine learning engineers, they're basically just building models. And that can be true, but don't think of this as a set in stone process. It's flexible to meet the needs the best way possible. Okay, so Avanesh is also adding, and his comments, he shows he has some real world experience here. The company for which I work has a very small team, and that happens. And so in those cases, it's really great to have this knowledge so you can jump in and say, hey, I took this course from these two yahoos named Guy and Tom, and they told me about a bigger process. I think we better be focusing on that. You know, you do get into situations like that. Even if there was a couple of really good software engineers on your team, that doesn't mean they remember everything from school. So it might bear on you to remember these things. So I think that's a good point.
And also here is something, sorry, Tom. Okay.
No,
when we have, by the way, when you have a small team, yes, you have more tasks to perform, but you have bigger harmony between the team. Because most of the time when you have small teams, all of them, they are able to deal with each other just like one, let's say, one unit moving together, just like the Roman fighters, how they are fight together. So yes, it's a lot of stress, but most of the time, small teams, they are doing great things. This is my experience. This is how I face it in the world.
Yeah, in fact, I've seen with small teams versus big teams, it's just pluses and minuses on both sides of the fence, both sides of the fence. Kimberly was asking a lot of questions around Greg's questions regarding testing. I want to point out, to me, even when you put in an assertion statement in your code, which is a way of saying, I want you to fail if you run into this situation, or I want you to check for this situation. To me, assertion statements are inline tests, but we will talk about how we want to test our code. In fact, you'll see us testing in various forms when we build our code, the way we write it with assertions. But then once the code is built, there are tests we want to put in place to see how it's dealing with new data coming in. These are the things we fix as we try to move toward automating a pipeline. Even if you can't automate the complete pipeline, you can at least automate large parts of it for your development process, and that's key. So we're going to talk about testing as much as we can, but would we cover all aspects of testing? I doubt it. A lot of the stuff we're covering is to fill holes in the excellent education space that already exists for machine learning out in the blog space, et cetera. We're not trying to insult anyone for not teaching what we're teaching. Let's remember, we're still at the early parts of the data science era, let's call it. And so we're just trying to jump in and say, this would help. We're teaching this, therefore. So for Git, which we talked about we're going to use, Alec is recommending to everyone to check out SourceTree and things like Autopool. And Himanshu agreed that SourceTree is pretty good. Thank you for that. I've never even heard of SourceTree. There's some people I follow on LinkedIn that are always looking for the latest Python things, and I love it. A note about Anaconda. I am not an anti-Anaconda person, but I'd like the students for the duration of the course to try not to use Anaconda. We're not going to give you a failing grade or something like that, or say you don't pass if you use it, but Anaconda does too much for you. And we want you to learn how to do what Anaconda would do for you. And it's really not that hard. And then, yes, we're going to, by the way, during this week, I'm going to be announcing some office hours. I'm encouraging the TAs to do the same to help people walk through the installs, the environment setups, things like that. And I'll be growing our code repo for the upcoming lectures. Guy, do you have anything to add to all of that?
No, I think I hope we cover the session in better way, because we are relaxing. At least we have the same question. We don't have a new questions, and this is make a difference for me as, let's say, a new teacher. I'm not that much expert on teaching. And sorry for the mistake appeared on this. By the way, really, this is to tell you how much I'm stressed when we are start speaking. This is a kind of responsibility. We like to help, we love to help, and we are getting good feedback from you, and we are learning from you, all of you. But still, it's responsibility. Really, when I'm starting stressed, because I feel if I speak something wrong, not it's allowed to be wrong, but once you are teaching, maybe it will affect somebody in a bad way. So really, when each week I'm stressed when I start this session.
That is so well said, and I want to piggyback on it. Because we're a family and you guys know we really care about you, please let us know, wow, that point really overwhelmed me. I did not understand that. But also say, that was so clear. Because remember, we want to teach this course better the next time. We want to bring you guys in as teachers in the future of this course. And also, everything we're doing in the class is helping us write our textbook better. So when you guys especially say, that was scary for me, or I didn't understand that, or I need more information on this part, or that part was perfect, that helps us help the greater community when we write the textbook to get it written really well. When we teach the next class on this, it helps us to get it ever better. As we bring in new lecturers, we'll be able to better help there'll be an experienced lecturer with a new lecturer, and the new lecturer will be doing most of the talking. That, by the way, that's not the case with Guy and I. Guy could probably teach this course, but we're both feeling like, oh, we're so glad we're writing the book and doing the course together, because he feels like I wouldn't have gone about it the way you are, and I like that. And I definitely feel the same way about him. And I couldn't have added all that. Well, maybe I could have added the software engineering stuff, but not as well as he did. And so all of this more together spirit is really leading us and playing out well.
Okay, so I will stop recording right now. Okay, thanks everyone. Thank you, Tom.